Good afternoon to everyone. I'm going to present a SPIDER project, which is the H2020 European project. SPIDER for safe and prelitiated high energy density batteries based on sulfur, rock salt, and silicon chemistries is a project from a call on materials for future highly performant electrified vehicle batteries dedicated to the development of lithium-ion batteries. The project started last year, beginning of 2019, and it lasts for 44 months. You have here the website where you can find all the information regarding the project. You have here the concept of SPIDER, which is a multidisciplinary approach to develop safe and long lifetime high energy density cells based on three pillars: the high capacity materials. At the cathode, we have sulfur, rock salt materials, and at the anode, silicon carbon composites in order to improve the energy density. We have the prelithiation, which is a process to introduce supplemental lithium to improve mainly the cycle life, and the development of advanced electrolyte formulations to improve power density and safety. You can find the SPIDER targets by 2022 with, for example, a high energy density, 390 Wh per kilogram. The project is organized around 4 cell generations to implement successively the developments. To finish with the overview, you have here the consortium of SPIDER with 14 partners, some universities, some research organizations, and some industrial partners. To work from vehicle design to develop materials and process, prepare batteries and test them, and to finish with recycling, exploitation, modeling, LCA and LCC for the economic and environmental assessment. We prepared the first cells generation composed of NMC 811, which is a nickel-rich commercial cathode, and silicon carbon composites for the anode. The electrolyte is a carbonate mixed with some specific additives developed during the first months of the project. You have the electrode dimensions. So we have pouch cells with electrode characteristics defined to fulfill the high energy density requirements. The pouch cell assembly process is shown here with ultrasonic welding, stacking, and the electrolyte filling before the final vacuum sealing. We prepared 68 single-layer pouch cells for electrochemical characterization and modeling activities. The pouch were distributed to partners for tests. And 10 additional stacked push cells with a higher capacity for abuse test. You can see on the graph the first formation cycles with a low rate cycle at C/10 and 3 characterization cycle at C/3. All the characterizations of the cells are detailed in the table here. We obtain a very good reproducibility regarding the nominal capacity with 2 mAh. The cycle life is still limited with 120 cycles at 70% of state of health, but the energy density is quite good, 480 Wh per kilogram of electrodes. If you compare with state of the art made of NMC 622 and graphite, we did this comparison in a benchmark study, the energy density is improved by 20%. In order to assess the Gen 0 cell lifetime performances at different uses and environmental conditions, we define a test plan based on vehicle specifications and requirements regarding data collections for modeling. You have the capacity loss, which is plot as a function of equivalent cycles calculated from the total capacity throughput divided by one cycle capacity. The cells were aged at 3 different temperatures within 2 different voltage windows, and using also a real driving profile within the same cycling window and at 2 different temperatures. We didn't yet finish the analysis of test, but we already saw that we can get 350 equivalent cycles until the cells reach 80% of state-of-the-art, state of health at 5 degrees, which is quite interesting. To improve the cycle life, we developed the prelitiation process. The graph at the top right shows the first formation cycle of a cell. You can see there is an initial capacity loss due to the solid electrolyte interface formation, the famous SEI. And there are also lithium consumption upon cycling. A solution to reduce the lithium loss is to introduce additional lithium within the cell. And there are various prelitiation methods which are possible. In the project, we are working on the use of lithium metal for direct contact prelitiation, the synthesis and the addition of sacrificial salts, and also the use of lithium metal powder. We demonstrated a successful introduction of lithium metal in the cell with a reduction of the initial capacity loss by 15%, and the capacity retention is increased. There is a gradation of the different quantities which was observed. So the prelitiation has the possibility to reduce the ICL and increase the cycle life. It means, as you can see on the two graphs, that it is possible to increase the specific discharge capacity thanks to the prelitiation. It means that the energy density will be improved. And you can see also that the cycle life is improved depending on the lithium content. We can get up to 123 cycles before to reach 80% of the initial capacity. It means that capacity retention is prolonged for prelitiated cells thanks to an higher lithium reservoir. The next step will be the implementation of a scalable roll-to-roll process. A carrier foil will allow to apply the lithium foil on the electrode, and there is an inline calendering which will be done to ensure the adhesion before rewinding. To conclude with the next steps, so we will do the assessment of performances improvements thanks to prelitiation. We are preparing the Gen 1 cells with mechanical prelitiations made by hand. The cells will be delivered at the end of the year. In the meantime, we will try to implement the process for the roll-to-roll application of lithium foil on electrodes. We have also other ongoing developments to reach spider targets, developments on the synthesis of high-capacity materials, and on the optimization of advanced electrolyte dedicated to the spider chemistry. To gather knowledge and demonstrate economic and environmental viability of the technology, we have ongoing interfaces and electrical characterization studies. We obtain a validated comprehensive model based on pseudo two-dimensional approach for Gen 0 cells, which will be useful to improve the next generations. The data collection for LCA and LCC, as well as the model started, And we also started the development of the recycling process dedicated to spider chemistries. You can follow us on our website and Twitter and LinkedIn. Thank you for your attention.